Hello class, welcome to our lesson today dealing with complementary and supplementary angles. We're going to learn what both of those terms mean and go through some example questions. And again, we want to work on kind of dealing with equations a little bit. So what we're going to start with is just a review of something that we talked about earlier in the semester and last year, is dealing with distributing. Now there's technically two ways to solve this, but I solve both of these questions using the distributive property. So remember, the distributive property is when you have a number or something out front like this, and there's a whole bunch of stuff with adding or subtracting in parentheses. So the distributive property would take the 3 and multiply it, okay, into both pieces. It could be division if there was a divide by here as well, okay. So that's something when it had a lot of things divided by one piece of a fraction. So that's another thing that you might want to think about. I distribute 3 times x is 3x, and then 2 times 3 is 6. So now I have 3x plus 6 equals 15. Now from here, you should be on autopilot. Okay, from here, it's a two-step equation that you're used to seeing. So to get rid of plus 6, I'm going to show minus 6 on both sides. I get 3x equals 9, divide by 3, and I get x equals 3. I'm still a little concerned that some of you aren't showing your work in a manner like this. These things are going to be helpful for you when you start to have more variables involved and you need to keep things organized. And so we're going to continue to work on that idea. Make sure that you're showing your work appropriately. For the second one, I'd like to show the distributive property here just to make sure we deal with the negative sign correctly. So negative 4 times 2 times x would be negative 8x because negative 4 times 2 is negative 8. And then don't forget, this is not negative 4 times 3. It's actually negative 4 times a negative 3, especially if you do plus negative 3 and do keep, change, change. So negative 4 times a negative 3 is positive 12. And then from there, it's a two-step equation. To get rid of plus 12, I do minus 12 on both sides. I get negative 8x equals 8. I divide by negative 8 because the coefficient here is negative 8. And a positive divided by negative would be a negative 1. Okay, here are two angles. This is the first angle x and the second angle y. Think of it like an ordered pair idea from a coordinate plane. So all this is doing is this would be filling in the chart. So this says what is x when y is 80. So if I go to 80 here on the y, I go over and figure out where it's at. It's right here. And I go back down and say, oh, that's 10. And I could go through all of these. If x is 10, y is 80. If x is 20, y is 70. X is 25, y is 65, etc. All down this list. You should notice something about when you take x and y and put them together and add them. 10 plus 80 is 90. 70 plus 20 is 90. 30 plus 60, 90. 50 plus 40, 90. 45 and 45, 90. So this is what's known as complementary angles. When you're dealing with complementary angles, what you need to know is that two angles that are complementary add up to 90 degrees. They complement each other, okay, and add to 90. This information is the same information, but dealing with supplementary. So you should notice something different. If x is 20, y is 160. If x is 30, y is 150. X is 60, y is 120. And if you go down the list and you add those together, 20 plus 160, 180. 90 and 90, 180. 140 and 40, 180. So two angles are supplementary if they add up to 180 degrees. Now, I don't have a great way of memorizing that, okay, other than knowing that complementary is 90 and supplementary is 180. Some options that I've heard people talk about is it's in alphabetical order, so complementary is first, so that's 90, and supplementary is 180. One that I've kind of heard from some students that I kind of like is that complementary here has one P in it, and a P kind of looks like a 9. It's backwards, but it kind of looks like a 9, which is 90 degrees. Supplementary has two P's in it, which is two 90s, which is 90 and 90, which is 180. I don't know if that helps you or not, but what you need to know is complementary adds to 90, supplementary needs to add to 180. Those are the things that you have to know to be successful in this section. Okay, so one thing that you might be asked is just, are these two things complementary? Are they supplementary? Or it could be neither, which is in most cases. So just add the two numbers up. If you take 110 plus 70, that's 180, supplementary. 41 and 49, 90, complementary. 128 and 62 is 190, so that's neither. What you don't want to necessarily do is kind of say, it looks like 90, so I think it is 90. Okay, check the numbers and make sure they add together. Like this one's kind of obvious. It doesn't make a straight line because remember, a straight line, okay, a straight angle would be 180. That's the same idea. Okay, this one's too big, but don't let that be your only way of like visually looking at it. Make sure you check the numbers and make sure they work as well. Notice here that to be complementary or supplementary, you don't have to be adjacent. Okay, so like these two angles here can be complementary even though they don't share one of their sides here. Okay, or a vertex. So these two add to 90. That's all that it matters. These two do share the vertex, so these are adjacent and are supplementary because they add to 180. These two are neither, not because they're not connected and share a side or adjacent, it's because they don't add to 90 degrees. Okay, so complementary and supplementary, there's nothing that says, oh, they have to be right next to each other. They just have to add to 90 or 180. Okay, and that's what you need to know for complementary supplementary. Okay, you're going to get some of these always, sometimes, never questions or true-false scenarios. These are really popular in geometry questions. You can probably expect to see some of these styles of questions as we go through these geometry sections. I think they're good questions to make sure you understand the definitions. So this says if x and y are complementary, then both x and y are acute. So if two angles are complementary, that's two angles that add to 90. Acute means less than 90, and wouldn't both angles have to be less than 90 to add to 90? So this is always acute. If x and y are supplementary, then x is sometimes acute, because if they're supplementary, they add to 180. Well, if one's less than 90, the other's greater than 90, which makes one acute and one obtuse. It doesn't say that x has to be the smaller one, so it could be obtuse. It also could be a right angle. If x is a right angle, then it is not ever acute. Okay, it's never going to be acute because a right angle is 90 and acute angle is less than 90. If x and y are complementary, then they are adjacent. They're sometimes adjacent for the reasoning we just looked at right here. Okay, for complementary and supplementary, there's no rule that says they have to be right next to each other. They could be, but they don't have to be. If x and y are supplementary, then they are sometimes vertical. Now remember, vertical means they're across from one another. Okay, so kind of opposite sides. They share the vertex but go opposite ways. The only way that's going to be the case is when it's like a coordinate plane like this, and everything's 90 degrees. So the two corners add up to be 180. That's the only time it could be vertical and be supplementary at the same time. But if there's one case of it, that automatically makes it sometimes instead of always or never. The next thing we're going to talk about is solving equations using the ideas of complementary and supplementary. Make sure you're following the directions. So this says tell whether they're complementary or supplementary. So these two here are complementary. Notice this red box in the corner. Remember, that means it's 90 degrees. So these two add to 90. There's a few ways to solve this, but I'm always going to go with the approach of solving equations because that's going to help you long term to review these ideas and move forward. So what we know is that these two things add to 90. So 4x plus 36 equals 90. And then from there, oh look, two-step equation. I subtract 36 from both sides, and then I divide by 4, and I'll get 13.5 as my final answer. But you got to make sure you're looking at it from that perspective in order to figure out the answer. You could subtract 36 right away and say 4x equals 54. That would also work. I think you want to make sure you know the approach of dealing with two-step equations still. Okay, the second one probably shows that a little bit better. This makes a straight angle, which means they're supplementary. And we add these two things together. So notice x plus x minus 4 equals 180. I combine like terms. X plus x is 2x. So now we have 2x minus 4 equals 180. And then boom. Okay, solve your two-step equation. Add 4 to both sides, divide by 2, and then you should end up with x equals 92. You could always check your answer on all these questions by plugging x back in and seeing if they add up correctly or not for any of those situations. Okay, this says draw a pair of adjacent supplementary angles so that one of the angles is 60 degrees. Now you should have your protractor when you're doing some of these questions. Obviously with things online, it's hard to ask those things, but we could still kind of say, well, how would you do this, or how would it set up? But in general, for this question, if you're trying to draw adjacent supplementary, that means there's two angles that add to 180 degrees. So what I would probably do first is just draw a straight line and put a dot in the middle to say there's the vertex. And then from there, either to the left or right, use your protractor and measure 60 degrees, and then that has to be 60 degrees, and there you've got it, because they already add to 180, and one of them is 60. The question mark here would be a 120, so you should be able to notice that this is a 120 degree angle at that point for that second angle. But if they say supplementary, I think your best bet is just to draw a straight line and put the vertex on, and then just draw the angle off of that. Here are 4 more always, sometimes, never questions. So it's the same idea of the first 4 that we looked at earlier in this lesson. I'm going to leave these 4 to you to try them out. If you think you have any questions on these 4 scenarios, please ask your teacher about them because these types of questions are going to show up from time to time, especially on an assessment. Teachers really like these types of questions, so you want to make sure that you understand where all 4 of these are coming from. And if you have any questions about that, feel free to ask your teacher about it, and they'll be happy to kind of explain why it is always, sometimes, or never. Okay, your homework today is all of 1 through 17 and 24 through 27. There's a mix of different styles of questions. Some will just tell you, are they complementary? Are they supplementary? Solve for X. Make sure for the solve for X questions you're showing work similar to what we did right here. Okay, so you should have something that looks kind of like this. It may be a little bit different, but you need some steps shown. And think about it as the teacher wants you to be able to do a two-step equation. I know there's lots of ways to find that answer, but the two-step equation approach and just solving the equations and combining like terms and then solving for the variable is an approach that you need to be comfortable with. If there's any other questions, feel free to let us know. Otherwise, have a good day, everyone.